This video, we're going to talk about the idea of oxidation versus reduction. Okay. And so what I want you to know is that we define oxidation as the loss of hydrogens or the gain of oxygens. Okay. And reduction is actually the opposite. So it's the gain of hydrogens and the loss of oxygens. Okay. Now, to be very precise, this is an or. So it's an or. So it's not both. Okay. So it doesn't have to be both. It could be or. So it's the loss of hydrogens or the gain of oxygens, and the gain of hydrogens for the reduction or the loss of oxygen. So either or. So I just want to make that clear. Okay. So if you approach these the way I think of it, then you'll always be correct. Okay. And what I usually think of is the idea of what is different around the carbon. What is happening? So I'm going to locate the carbon that whatever, is taking place. I'm going to locate where the carbon is and whatever the reaction is taking place. I'm going to look for what is different. Okay. And so what do I mean? Well, let's take a look at the examples. Okay. So if I look at this, I see that I have an alcohol and it went to a carboxylic acid. Well, what is different? Well, it looks to me as this is the carbon of interest. Okay, this is a carbon of interest. This is where the carbon, something happens. Okay. And so if I'm looking at this, well, to me, it is very apparent that, remember, we have two hydrogens here. Okay, we have two hydrogens here. And the idea is that, well, it looks to me going from here to here, I lost those two hydrogens. Okay, so going from here to here, I actually lost those two hydrogens. Okay, and I can see that that is something that's different. And so in this case, we lost those hydrogens. Okay, we lost those hydrogens. Well, this is actually oxidation. Okay, forget about the gain of the oxygen also. Okay, I mean, you could think of it like that, but again, I usually like to fulfill one of these to make it simpler and not both. Okay, so notice that I lost two hydrogens going from here to here. So this is a simple case. So this is oxidation. Okay, now what about this one? And this is where it gets a little bit tricky. Again, I usually think of what is different. And so what do I mean? Well, if I look at, this is my carbon of interest, this middle carbon here. Well, if I look, they both have an oxygen in common. And so I know that is not different. That is not different. That's not how I want to look at this, because they both have an oxygen in common. And so I'm not going to look at the fact that I gain oxygen or lost oxygens. Okay, I'm not going to look at the fact that I gain oxygen or lost oxygen. Okay, what I'm going to look at is the fact that I'm not going to look at hydrogens. I'm going to look at hydrogens. And so if I'm looking at my carbon of interest, I notice that, to the bond, I have no hydrogens. I have no hydrogens, but however, I'll gain two hydrogens over here. Okay, and because we've gained two hydrogens, this is actually reduction. So this is actually reduction. So this is actually being reduced. Okay, so we reduce a ketone to alcohols. That's what we say, we reduce. Okay, and some reducing agent, lithium aluminum hydride, all that good stuff. Okay, so this is actually reduction. And see the reason why I like to think of it as different. Okay, because if we had to think of this as, okay, we gain an oxygen. Well, we gain an oxygen, you'll think this is oxidation, when in fact it's not. This is actually being reduced. And so that's my thought process. Always look at what's different. That's what I want to look at. Now, what about this one? Well, again, notice, looking at my carbon of interest, I have two oxygens. So therefore, I'm not going to look at the oxygen. I'm going to look at my hydrogens. So eliminate oxygen. We don't care about the oxygen. We want to look at the hydrogens, okay? And so if I look at this, well, we have a hydrogen here, and we also have a hydrogen in alcohol. Well, notice going from here to here, we lost those two hydrogens, okay? And so if I'm looking at this, well, the loss of hydrogens is actually looked upon as oxidation, okay? So the loss of hydrogens is looked upon oxidation. So this is actually oxidation. So again, look at my thought process. They both have an oxygen in common, so I'm not going to look at the fact that I gained an oxygen and lost an oxygen. I'm going to look for what's different. And so because they both have an oxygen in common, I'm not going to look for that. I'm going to pay attention to my hydrogens. And it's the same thing that happens here. Okay. So let's continue. Now with alkenes, we got to be very careful. Alkenes could be both oxidized and reduced. Okay. So again, with alkenes now, it becomes a little bit, I guess, tricky. Okay. But remember, we have one hydrogen here. Okay. And this one, in this case, not much difference. Okay. This is just straightforward. We have two hydrogens here, and over here we actually gain two more hydrogens. Okay. And remember, we said the gain of hydrogens, we consider that to be reduction. So this is being reduced. Okay. Now again, what about this one? Well, to me, it looks as if I have a hydrogen here, I have a hydrogen here. Okay, well, notice that they both have hydrogens in common. So what am I going to do? I'm not going to pay attention to hydrogens. I'm not going to pay attention to oxygen. And the fact that I've gained two oxygen, simply means that I actually oxidized. So this is actually oxidation. And so the good reagent to use in this, and actually to get this, is actually potassium permanganate. Use potassium permanganate, I think in cold conditions. If you use potassium permanganate in cold conditions, you'll actually get the diol. And so that's the idea. So, okay, so again, remember my thought process. If they have the hydrogen in common, look at the oxygen. If they have oxygen in common, look at the hydrogens. That's how you look at it. Do not look at both, because you'll get stuff wrong.